to verify what I've done is, well, really nobody has sent any emails asking for a specific topic, which is probably a good thing because quiz scores are actually kind of high right now, which is always exciting. But I did go through and find some common themes, mistakes that I've seen, and just wanted to talk about a few of those common problems. So, oh, Tanya, you're very tired. I can relate. I still have coffee out. Maybe you guys do as well. So welcome. Let's go ahead and jump in and see if we can jar any questions and comments as we go through chemical equilibrium, trying to wrap up our chapter by Sunday night. You know, this is a question that I saw several people actually trip over on their first attempt quiz. And then I noticed that as they did attempt 2 or attempt 3, that this concept actually scored well. But what we're looking at is a chemical equilibrium, and we're given the equilibrium constant as a value of 4.34 times 10 to the negative 3. And this question is just really asking, what does that number mean? And I think right at the very first start of the first lesson, when we described the equilibrium constant is just a number, it has no unit associated with it, but it's the magnitude of the number that a chemist finds interesting. And we said that small numbers are favoring the reactants, that what you're doing is kind of making sure that the reaction favoring to the left, the reactant side, ends up to be a small number. If you have a very large number for the equilibrium constant, you know that products are being favored and that the forward reaction is being favored. So really all I had to do to answer this type of question was look at the magnitude of the number. And we could see that this number is quite small. And based on the number, you know, the size of that number, we know that the reactants are being favored. Reactants predominate. But I wanted to comment, I think what might trip people up is that this choice C often was selected in saying that only reactants are present. Remember, that's not true because it is a dynamic equilibrium. We have the forward and the reverse reaction occurring. We're just favoring one side over the other. I think that question is a very quick fix. If you happen to see something like that, know that reactants and products are both present. One would be favored versus the other. You know, and one time I saw on a quiz where it came out to be the equilibrium was exactly 1. And then we select the answer where both reactants and products are in the same amount. Alrighty, so good enough. That was an easy one to just talk about quickly. Le Chatelier. Okay, so with this particular question, I selected it because it's asking us to go through a series of conditions and decide how the reaction would proceed. All right, so we have this decomposition of ammonia in dynamic equilibrium with its elements. So NH3 decomposes into elemental nitrogen and hydrogen with that ratio of 2 to 1 to 3. Here we're being asked, what would be a stress in terms of measuring hydrogen in the reaction that will make the hydrogen value increase? Okay, so looking at what is our goal? We want the hydrogen to increase. So really what I'm looking at is what type of stress could we apply and force the reaction to shift to the right? That's just me interpreting what it's asking me to solve for. What stress would cause it to move to the right? That's going to make the hydrogen increase. And then we just have to read each choice one at a time and decide, yes, it will move to the right, or no, it won't. For example, letter A says, what if we remove ammonia? So I like to just make that visual. If I decrease the ammonia, the system wants to counteract that to do the opposite. It wants to make more ammonia, and therefore I know I got to point at it to make more. So letter A, I know is going to shift to the left, and that's the opposite direction of what we want. Letter B. If we increase the total pressure by the addition of helium, and I went on and on, I know, in the Le Chatelier and talked about the presence of an inert gas, absolutely no effect on the system and equilibrium. And if I think about helium being involved in this, it's not part of the studied reaction. There's no helium anywhere in the left or the right side. So adding an inert gas has no effect on the dynamic equilibrium. So still not letter B. Let's keep reading. Letter C says, if I decrease total pressure. Now the total pressure, that comes from the number of gaseous moles on the left side as compared to the right side. So if I decrease pressure, that's the stress, the system wants to do the opposite. So it wants to increase pressure, and increasing pressure is going to happen by the side that has more gaseous moles. And so when I go up to this equilibrium, I notice here on the left side, I have a total of 2 gaseous moles. And on the right side, there's a total of 4 gaseous moles. The side with more gaseous moles would be favored because the number of collisions increases with the more and more molecules. I think I like letter C. If I lower the pressure, the system wants to create more pressure, so it's going to make more particles, and that's exactly the side that we were looking for to push to the right. I can kind of eliminate choice D and E as well, just to kind of verify. Decreasing the total volume, well, we have to apply Boyle's law there. If you decrease volume, that's the same thing to me as saying increasing pressure. So when I put the molecules in a smaller container, they hit more frequently, therefore the pressure rises. And I know the opposite of more pressure is low pressure. So this actually would favor the left side, exactly the opposite of letter C. And of course, letter E, if I add nitrogen, it will shift left as well. So the only choice after going through and talking about each one of those stresses is letter C, to accomplish the goal of pushing to the right to make more hydrogen. Let me pause and give you a moment of think time over Le Chatelier and see if there's any other concept you wanted to bring in before we move to some more calculation type questions. Comments, turn your mic on or put it in the chat. You even tell me if you're feeling confident. Unless you type, you can't type. Okay, no comments. So I'm going to go ahead and go to the next slide. Let's give a read through of what we see here. High temperatures, equal concentrations of hydrogen or iodine are initially put in the flask, and here's our equation. So I'm going to just take a moment and rewrite the equation so I can write things under it. H2 and I2 in dynamic equilibrium with 2 HIs. It tells me initially I have 0.16 moles, both the hydrogen and the iodine, and that's per liter. And so those are actually molarity units. And of course, initially we know that there's no product. When the equilibrium is reached, the concentration of hydrogen decreases to 0.036 molar units. Let's find the equilibrium constant for this reaction. So I can say initially and equilibrium, I have 2 pieces of information related to hydrogen, and that lets me easily fill out this particular box for the change role in hydrogen. And then I know I can use that to figure out all of the other components. So when I take 0.16, oops, 0.16 minus 0.036, hydrogen decreased by a value of 0.124 molar units. And I can see that the hydrogen to iodine stoichiometric ratio is 1:1. So for every 1 mole of hydrogen consumed, the same number of moles of iodine are consumed. So now I also know that iodine was consumed by 0.124 molar. And what I can determine here for the HI, based on the stoichiometry, twice as much HI gets produced, which if I double that comes out to 0.248 molar units. So again, remember this change role is always related to the stoichiometry, just thinking about mole to mole ratios. Now at equilibrium, 0.16 minus 0.124 is also for the same value here for iodine. And then 0.248 molar units will be the equilibrium concentration for HI. We need, friends, to calculate our equilibrium constant, the products over the reactants, where the coefficients become the powers with which we raise each molarity unit. So with this value, we had the concentration of HI squared, 0.248, and then the bottom number happens to be the same, so I can square 0.036 as well on my calculator. Let me ask you to hit that with me just to be sure I'm hitting it correctly on an early Saturday morning. 0.248 squared divided by 0.036 squared. And here my screen reads 47.46. I'll just put that there. Let me know if anyone else found the same answer so I have confidence in my calculations. Are calculators on? I'm just going to wait until someone says, yep, I got the same thing. Oh, thank you. Awesome. Okay, that makes me feel better. I got the same answer, Ryan. Awesome. Thank you, calculator friends. Same. Beautiful. All right, third charm. That one was, I would say, mildly easy, right? Not a lot of math, calculations in that, pretty straightforward. So things are good there. Here we have an example. Again, I'm just trying to pull various types of equilibrium calculations, and they'll progressively get a little harder. Here we have an example where I have CO with 2 molecules of hydrogen giving me methanol, CH3OH. In this experiment, 0.42 moles of carbon monoxide were placed in, the same value, 0.42 moles of hydrogen, and this is in a liter, so we're good there. And at equilibrium, we have 0.29 moles remaining of CO. Now with this problem, I selected it, even though it's so similar to the last screen, there's one twist that I think I saw students missing, and it just is a quick comment, and I'm sure that we can fix it quickly. I can do the change row on the carbon monoxide just by simply subtracting. I can find 0.42 minus 0.29, and I can find that the carbon monoxide levels changed by 0.13 molar units. It decreased by 0.13. And I think sometimes we get, just maybe in a hurry perhaps, when we figure out that change row and we just carry the same number all the way through. But remember, we have a 2-to-1 stoichiometric ratio for the hydrogen. So if this is 0.13 moles of carbon monoxide, I just wanted to remind you that you need to double that when you consider how much hydrogen is then consumed. That's supposed to be an M. So this ends up to be 0.26 molar units are being consumed. And that's the only thing that I saw go wrong for people as I tried to analyze quiz results last night, when I saw that same 0.13 get carried through. So 0.13 doubled, 0.26 is consumed. And of course, since this is the same stoichiometric ratio, that becomes 0.13 molar. So a 1-to-1, but I needed to double for the hydrogen. Just the only thing that I saw possibly as a mistake there. This, of course, becomes 0.16 molar when I subtract, and this becomes 0.13 molar, carrying that down. We have all of the equilibrium concentrations and are ready to solve for equilibrium by placing the concentration of the product over reactants. Remembering to square the hydrogen value. I see, was the table mandatory? So I'm not quite sure how to answer that. Is the table mandatory for me to figure out what the equilibrium concentrations are? It is for me. I need that visual. I needed to know this change in order to determine everyone else's. So that's why I subtracted there and filled that out. You're going to see me fill out an ICE table just to help visual learners like myself keep track of, I need this row, but I need to figure out the row above it to get there. So that's kind of how I out loud think. Okay, you're welcome. So let me hit this just to be sure I'm doing that right. 0.13 divide by 0.29 and divide by 0.16 squared. How about 17.5? And I'll look to see if anyone else got the same. Got that. Sweet. Okay. Oh, I pulled up a couple of what I would say, just a little bit of a review of how equilibrium constants change if we distribute a number through the coefficients, or if we reverse the order, kind of going back to the very first chapter when we talked about Hess's law. We're giving this initial reaction, I'll just write it with you. We have 2 units of NO reacting with oxygen, and it's in dynamic equilibrium with 2 molecules of NO2. And it tells me the equilibrium constant here is 5.4 times 10 to the 13th power. So a very large number, favoring products for sure. What I see in the next equation is 4 units of NO plus 2 molecules of oxygen going on to 4 NO2s. And we're asked to solve for this equilibrium constant. So there was a section in our lessons, in our video notes, where I talked about whatever you distribute through a reaction, that becomes the order with which you raise the K constant to. So for instance, I can see that I distributed a 2 through that initial reaction, right? Because 2 doubled is 4, 1 doubled is 2, 2 doubled is 4. So that second reaction is twice as big. Now remember, in order to solve for the new K constant, we don't double it, we don't go times 2, but you raise it to that power. So we have to take 5.4 times 10 to the 13th and square it to find that new K constant, which will make it even bigger. 5.4 to the 13th power squared. And my screen reads 2.9, I'll say 2 times 10 to the 27th power. Whatever you take as a coefficient and distribute through a reaction, that becomes the power with which you raise the original K constant. The other note I remember is if you reverse the direction, you take the reciprocal of the K constant. And if you add equations together, you multiply the K constants. So there was a section we went through many examples in our note packs, and this is an opportunity to kind of bring you back to that section and what it might look like on the test. Comments on this one? Good. I'll take a quick sip of coffee. You just let me know if I'm moving too fast. Thank you. I saw a thumbs up. Yay. Oh, this exact same question, just different. How do you like that? Again, I just saw a few places where people tripped on this, so I grabbed a few example questions on this particular topic. Here's my original equation: 2 units of chlorine, 2 units of water, making 4 HCl's and 1 oxygen. And it's giving me the equilibrium constant of 7.73 times 10 to the negative 2. What is the equilibrium constant for the reaction below? And let's decide. It looks like we distributed a half, didn't we? Like if we cut this in half, I don't mean it here. If we distribute a 1/2, cut it all in half, we end up with a new target equation. 2 cut in half is 1, 2 cut in half is 1. Yep, 4 to 2, 1 to 1/2. So again, just a reminder, what we're so tempted to do is to take the original K constant and multiply it by 1/2, because that's what we would do in thermodynamics with a delta G or a delta H, but not with equilibrium constants. We raise it to the 1/2 power, and that becomes the new K constant for our reaction. So the rules are different between delta H, delta G thermal properties and these K constants we're working with now. So let me hit that for us: 7.73, negative 2 power, and then raised to the 0.5, which is square root. You could accomplish that the same way. 278. Those aren't tough. I just wanted to be sure that we hit on some examples there, just to remind us that the rules are different when I distribute a, oh, do you have an example? Yeah. So, yep, let's see if I can find one. An example solving for equilibrium of molarity when given a K constant. Let's try this one, see if this hits it. The equilibrium constant, I'm going to rewrite the equation just to copy it with you, and I can tabulate things under it. NH4HS is in equilibrium with NH3 and HS, and the constant is 1.8 times 10 to the negative 4. We can see that the expression is going to relate to the ammonia, which is a power of 1, times H2S, which is a power of 1. And since this is a solid, we know that it simply drops out. And this one actually is not that hard. We have ammonia, which is what we're looking for. And I can see that the ammonia and H2S are exactly the same value. We have a 1-to-1 ratio. So let's also call that X. This problem becomes actually quite simple. And Joe, I know you're looking for something more difficult. I'll pull that up in a moment. This one actually just becomes where the 1.8 times 10 to the negative 4 is x squared because we're already at the equilibrium row. So it could be where you say, do I need the ice chart? And the answer here is no, because we're already looking for equilibrium values. And so just square root your K constant and you'll have the molarity of each reactant since they are the same value. (1.8) E negative 4 square root. To answer or to look for something a little more interesting to kind of relate to Joe, I have some, yes. I'm going to come to probably one that I find most interesting and then maybe work backwards. So this would be probably a question that I would consider one of the most challenging, not conceptually, but mathematically. And it allows me to talk a little bit about your calculator as well, your solver, if like we talked about your quadratic equation formula. So let's kind of back up and say, let's read through this question and see what it's asking. I have two H2S in equilibrium with two H2s and S2. And these are all in the gaseous phase. Kp is given to me as 3.2 times 10 to the negative 7. And I know the expression would be the partial pressure of hydrogen squared, the partial pressure of S2 over the partial pressure of H2S squared. So those are it's just the expression products over reactants. Let's read what it gives us. It says initially, atmospheres of H2S are present. And if the reaction is allowed to go to equilibrium, get that out, what is the pressure of S2? At equilibrium, we'd like to know this. So filling out the ice chart, we can think of, this is just how I operate. When I think about how, what value to let stand for X, I like to let X be the value that has the coefficient of just 1. And so this becomes minus 2X. This becomes plus 2X because it's a 2 to 2 to 1 ratio. And so at equilibrium, I have 3 minus 2X for the value representing hydrogen sulfide. I have 2X representing the value of hydrogen, and I have X representing the value of the sulfur gas. Given the Kp, we're asked to solve for X, right? And I'm going to just put my paper up higher so I have room to solve. Kp was given to us as 3.2 times 10 to the negative 7. The 2X represented hydrogen. Its coefficient was a 2, so it had to be squared. The value of the sulfur was given to us as X at equilibrium, and at equilibrium 3 minus 2X was hydrogen sulfide, and based on its coefficient, it also had to be squared. So this would be one, Joe, where I would say this is probably, I would say one of the more challenging, simply because we've got some higher X values than normal. Let's do this. I'm going to just go slow through how I'm solving for X. Well, see, 3 minus 2X squared, I know I have to FOIL that, if you will. So I'll just do first, outer, inner, last, simplify 3 minus 2X times 3 minus 2X. 3 times 3 is 9. 3 times 2 is -6 there, minus another -6 plus 4x squared. So I can simplify 9 minus 12x plus 4x squared as the result of the foiling of those two parentheses down below. I'll simplify up top here as well. 2 squared is 4. Squared times x is x cubed. So that's what we have simplified on the top so far. Let me just rewrite what we have so we can kind of organize. We have 3.2 times 10 to the -7 is equal to 4x cubed over 9 minus 12x plus 4x squared. Our next step is to cross multiply and bring this bottom over to the left side. That was me bringing what was below the fraction over the left side, and now I have to distribute. I need to distribute that k constant through that parenthesis one at a time. So I'll take the 3.2 times 10 to the -7th and multiply it by 9, and then by 12, and then by 4, one at a time, so I can simplify this value. I'm going to change color to purple. 3.2 times 10 to the -7th times 9. I found 2.8 times 10 to the -6th. 3.2 times 10 to the -7th times -12 minus 12. I'm going to have minus 3.84 times 10 to the -6th x. And one more time, I have to take that k constant and multiply it by 4 as I distribute through, and that will come out to be positive 1.28 times 10 to the -6th x squared is still equal to 4x cubed. Now we know to solve for these complex formulas, we need to set it to 0. So I'm going to rewrite one more time what we have so far. 2.88 times 10 to the -6th minus 3.84 times 10 to the -6th x plus 1.28 times 10 to the -6th x squared minus 4x cubed, all equal to 0. Now, this is beyond a quadratic equation. A quadratic equation would have an x squared, an x, and a number with no variable. This has an x cubed, an x squared, an x, and a value of no x there. So this is where I would say, if you've not introduced yourself to your solver on your calculator, it is high time that you made a friend and let your calculator do this hard math for you, where I look at this challenging equation and I can solve for it by programming my calculator to do all the hard work for me. If I may, I'm going to just slide back up here because I typed for you, if you were unfamiliar, how to use the solver feature on your calculator. Let me walk through that with you, and I'm going to try my best to hold it up to the camera as well. So if you happen to have your calculator and have never used solver before, your world is about to be rocked, because it will make your math easy. It's just programming your calculator and solve it, and you don't have to do any of the algebra that way. Once you get it, all your variables set equal to 0, let the calculator solve it for you. Okay, so first I wanted to just show you, do you see on your calculator underneath the second, which is a blue, underneath the alpha, which is green, there's a button that says math. If you can find your math key, we're about to find your solver. Okay, so I'm going to clear your screen, hit your math. So that's what it says here in step 1. Find your math key. It's the third from it's on the left side, third from the top. When you hit that math key, you want choice 0. Right now on my screen, I see choices 1 through 7. The fastest way to get to choice 0 is just to scroll up 1, and now the cursor is on 0. See how it says solver? Choice 0 is solver. Friends, you can also scroll down and get to choice 0. You just have to go through choices 1 through 9 to get there. Pressing up gets you there faster. So that's where the solver is choice 0 in the math feature. So I'm going to hit enter. I have and it has 0 equal. Are you there? Is this helping? Equation equal. And literally, we're about to just type in this equation as we see it and press solve, and you will have an answer. So just as you see it, you have to type this answer in. The only difference now is, let me show you where the X is. On your calculator, the X is right here next to the alpha. This button right here is where you see the X for the variable. So I'm going to type in where it says 0 equal on my solver. I'm going to type in exactly what I see on my screen right here. And anytime I have a variable X, I'm going to type that in using this key right next to the alpha. This is your X key right here. So I'm going to type in 0 equal 2.88 e negative 6 minus 3.84 e negative 6, and then I'm going to use my X key. That's the key that's underneath where it says link there. Then I have my plus 1.2 e negative 6. And now I have to make it read x squared. So I'll make sure I hit x and then square it. And then minus 4x cubed. To do cube, just use the caret key and then cube. So I've just literally typed in to my screen. I know it's kind of hard to see that, but that's how I just typed it in. And now I have the equation as it appears here. When I come back to the directions, you have to solve this equation. Now, this might be new for you. To solve, it's the green button on enter. Look at your calculator. You see the word solve sitting above enter. Way down here is your enter key, but you want to solve. So that means you have to press the green alpha. See how they're color coordinated? Green enter is solving. Don't press enter as if you're going to solve the problem without that alpha problem, the alpha key first. You're asking the computer, the calculator, to solve this equation first. The thing with this is because all these variables have two possible answers, a positive and typically a negative, it asks you to make a next guess. You're not expected to know the answer, but it does want you to make a guess. And so I just always put the value 2 because it absolutely doesn't matter. You could put 5, just make a guess and then solve. And when you do that, you will get the answer on your calculator screen. When I solved, I have 0.008927 as the value of x. Now I know you're going to need a minute because this is brand new. You want to practice this. Practice, practice. Yeah, and like I said, if you have a different calculator, TI-84 plus, well, mine is a TI-84 plus. Yours might be a little different addition, but I think the key sequence will be the same. And see, missed step. Let me go back and just list those steps for you. And I also, how about if I put in the chat, you, to be brutally honest, there's nothing you can't YouTube search and walk through this as well. So I found this link just to help me go through the steps of Solver. My point of bringing this problem up to you is that when you are practicing these types of problems and you get a doozy of an equation like this, right? When I look at this and say, how in the world am I supposed to solve for x when I have all of these things in there? My answer is, I don't want you to spend the time with the algebra. I just want to know the answer. And if I can use my solver function on my calculator to just type in an equation and give me an answer, that's what I would encourage you to do. So if you don't find this answer yet, just make a note to say, I think I'll YouTube how to use the solver on my calculator, whatever the feature is, whatever kind of calculator you have. There's a YouTube video on that, count on it. And they can walk you through how to use that. And even if you don't have the quad formula, using the solver will get you to the exact same place. Now, when I solved, it came out to be 0.08927. I would end up using somewhere around 0.009 was the value of x. And just to kind of bring it back to the overall question, that's what we were solving for, was the partial pressure of S2 at equilibrium. So when I solved for x, that was my final answer. Okay, that was a lot to just process for a moment. Looked like practice for me. Yeah, and you know, it's supposed to make it easier, and I promise you that eventually it will. You just have to get familiar with how to punch it into your calculator. But for me, I don't, like I said, I don't want you to get caught up in solving for an x in a long algebraic formula. I would rather just have it punch into the calculator. So I'll just repeat the steps. I find solver, right? So I'm just going to hit my math. I hit up to find choice 0, and I'm at solver. And my equation is still in there from the last time, but you can go up and clear that. So this is what you want to have on your screen. And I know it's hard to see on the, it's like a dark light, but it just says equation solver, equation 0 equal. And whatever your equation is, just type it in. Type it in using your number values and the variable x coming from right here. The other key there is not to hit enter, but to hit solve on your enter key. And that means you've got to hit alpha solve, and then you'll see what x would equal. And I know there's always two answers for these types of problems if it crosses over the x-axis multiple times. But we don't ever really consider the negative value in chemistry because we don't have negative pressure or negative molarity. So we're looking really for the positive answer. Ooh. Now, as I said, you asked for a doozy, and that was one because we had x cubed, x squared. I would say the most common problem is the quadratic equation problem. And I think what I'd like to do is to have us work one of the quadratic equation problems and then try solver again. All right, so let's pause that problem. If you've written down your final answer for X, then you can come back and practice your calculator sequence. The X when I solved 0.0089, so I rounded to 0.009. And just make sure you take the time to figure that out on your calculator so you can be quick, efficient. But let's try one that would involve a quad formula instead. We'll look at this one with our solver as well. So fresh start. SO2, Cl2, S2, and Cl2 in equilibrium. Kc is given to us as 0.045 at a specific temperature. We have 0.075 molar of SO2Cl2 initially. What is the equilibrium concentration of chlorine? So initially, we know there's no product, so I know I can put those in as 0. This is a pretty nice one because all the coefficients are 1. So we know the reactant will decrease by a value of X, and each of the products will increase by a value of X. So at equilibrium, we have 0.075 minus X of our reactant, and then simply X and X for each of the products. You can clearly see that this is much friendlier algebra than the last problem. And I just wanted to say, this one I know it would be more representative of the level of question you'll get. The Kc was given 0.045. That will be set equal to X squared over 0.075 minus X. Our job is to pull out X. So I'm going to distribute 0.045 through that parenthesis. Just kind of simplifying so I can get it into an equation that's set equal to 0. .045 times 0.075 brings me to 0.003375 minus 0.045x, and I'll just bring the x squared over as is, and we set it to 0. Let's give a minute to type this to your solver and see if you can follow those processes. Type it in exactly as you see. So again, we want the math key. Go to solver, which is choice 0, and type the equation in, and then solve. Don't hit enter, but hit solve, which is the green first, green alpha button, and then the enter. I'll do the same thing and see what we find. When you hit solve, remember you have to make a guess and then solve, just to make sure that this guess is a positive number. And I'm telling you, I just type in 2. It doesn't matter what number you type in, just that it's a positive number, and it's going to give you the answer that's closest to that value. Let me pause a minute and see if you're having success at finding the same value as I did for X. Hmm. So, Joe, I see that you're getting that same answer again, which obviously is what it is saying bound. But what do you see up above that says x equal before the line that says bound equal parenthesis? Hmm. Um, so, okay. When you finish typing in your equation, and I don't know how to make that any brighter, but when you look at that equation on your calculator and you x equal and then nothing is there, just make a guess again and then hit solve. And again, I get the same answer. So I think what might happen is that when your cursor is sitting over the x equal, which is just directly above the word bound on your screen, just an actual number there and press alpha enter to solve and see if that fixes the problem. And again, if you're not getting that, the solver feature, I would just recommend taking 3 minutes out of your day and doing a YouTube search of, and they'll, can kind of show you how, yeah, exactly. If you have a quad formula, I know that I have and thank you from the last review session, I fixed it. Under my program, I have quad. So that could be another fast where you just type in A, B, and C. That's another way to go about it. But all I'm doing is encouraging you to learn your calculator to solve these types of equations so much faster than having to work through the algebra part. And I know that that's kind of weird to hear me say is I don't care about the algebra, I just want the answer. But especially when you're being timed, you really want to spend more time solving the chemistry problem and not necessarily trying to get X out from these long equations. So just make a commitment, and I'll tell you, it will pay off dividends because next chapter we have equilibrium, and the next chapter we have equilibrium, just different topics of it. And these equations aren't going away. So the faster you can become in solving them by letting your calculator solve for you, I think you'll be, it'll pay off. So yeah, if it's not, just figure it out later, as you say, Joe, but it's really worth it to let your calculator quote solve problems. And it's not hard. You just have to kind of figure out the sequence and get familiar with your own calculator. Anything else that you'd like to ask me before we were to end our review session today? A topic I did not yet hit on.
I kind of missed the first 5 minutes because I just woke up and I forgot about the test review.
Sure. So I did record, and I'll be sending that as well if you wanted to look it over. But the first things I did in the beginning was some little bit of Le Chatelier, so non-computational questions, more conceptual. So we worked some Le Chatelier problems and said, what will cause it to shift left? What will cause it to shift right? And that's probably about the time you joined us. So that would be about the first 5 minutes of those slides there. And certainly just replay it quick when I send a link out if you.
Sounds good.
Okay. Any topics though, quickly, any last questions before we were to conclude? If you do, I'll just say, please stay on the line. I'll wait until everyone is gone. And if your questions are answered, best of luck on your test this weekend, and have a nice snowy Saturday. Thank you. You have a great day too.
You too.
Okay.